Hello students, welcome to video lecture revision, chemistry, haloalkanes, haloarenes, lecture 2.1. Classification of haloalkanes. Haloalkanes are classified into monohaloalkane, dihaloalkane, trihaloalkane, depending upon the number of halogen atoms present in a molecule. Example for monohaloalkanes, ethyl bromide. Dihaloalkanes are further divided into two types, vicinal halides and geminal halides. Vicinal halides are the one where halogen atoms attach to adjacent carbon atom. Example 1,2 dichloroethane. Geminal halides, halogen atoms attached to same carbon atom. Example 1,1 dichloropropane. Monohaloalkanes are classified into primary, secondary and tertiary alkyl halides depending on the carbon atom to which the halogen is attached. A primary alkyl halide is the one where halogen is attached to primary carbon atom. So example is methyl chloride and ethyl chloride. Secondary alkyl halide is the one where halogen atom is attached to secondary carbon atom. Example can be isopropyl chloride. Tertiary alkyl halide where the carbon atom which is tertiary carries the halogen atom. Example is tertiary butyl chloride. Monohaloalkanes are also classified into vinyl halides where the halogen atom is attached to sp2 carbon atom. Example 1-chloroethene. So in ethene the halogen atom is attached to double bonded carbon atom. Allyl halides where the halogen atom is attached to allylic carbon atom. Example 3-chloropropane. So halogen is over here and this carbon is allylic carbon because it is attached to a double bonded carbon atom. Nomenclature of haloalkanes. The common naming of haloalkanes. The common name of haloalkanes is alkyl halides. And the IUPAC system, the prefix for halogen is halo. Some of the examples for nomenclature: CH3Cl, the common name is methyl chloride, the IUPAC name is chloromethane. Second example, CH3CH2Cl, where common name is ethyl chloride, the IUPAC name is chloroethane. CH3CHClCH3, the common name is isopropyl chloride because chlorine is attached to isopropyl group. The IUPAC name is 2-chloropropane because the chlorine is attached to the second carbon atom in the primary chain. This compound, the common name is isobutyl bromide, and in IUPAC system the same compound can be named as 1-bromo-2-methyl propane. So CH3CH, CH2Br. So bromine is attached to a primary carbon atom and the compound can be written as this is the bromine atom. So this is the isobutyl group and bromine is attached to isobutyl group. So common name is isobutyl bromide. Preparation of haloalkanes starting from alkanes. Alkanes are subjected to halogenation in presence of sunlight. They form respective haloalkanes. The reaction follow free radical mechanism. The order of reactivity of halogen is fluorine greater than chlorine greater than bromine greater than iodine. Fluorination is explosive. Chlorination is very fast. Bromination is moderate rate and iodination is very slow and reversible. The order of reactivity of hydrogen atoms of alkane is 3 degree hydrogen is more reactive than 2 degree hydrogen, and which is more reactive than 1 degree hydrogen, which is more reactive than methane. This depends on the stability of the free radical. The order of stability of free radical is also 3 degree greater than 2 degree greater than 1 degree. The reaction can yield a mixture of mono, di, tri and polyhalogenated compound. So it is not exactly a suitable method to prepare monohaloalkanes because we end up with mixture of products in the reaction. The general equation is RH plus Cl2 in presence of H nu to give RCl plus HCl. From alkenes, the reaction of alkene with hydrogen halide to form alkyl halides, it can be through Markovnikov addition of HCl. If you consider the given example, the HCl is added across the double bond according to Markovnikov rule. The reaction is an example for electrophilic addition reaction. The reaction follows Markovnikov rule, which states the negative part of the adding molecule, that is addendum, will add to the carbon with least number of hydrogen atom. So if you consider the double bonded carbon atoms here, this carbon has 1 hydrogen, this carbon has 0 hydrogen. So you can see in the product, halogen is attached to carbon with lesser number of hydrogen atoms. The reaction have carbocation intermediate. So first step is addition of HCl, addition of H plus, which gives a carbocation intermediate. And once the carbocation is present, rearrangements are definitely possible during the reaction. If HBr is used in presence of peroxides or light, the reaction follow anti-Markovnikov rule and it follow a free radical mechanism. We'll take an example. What would be the product for the following chemical reaction? So first reaction is direct addition of HCl and second reaction is addition of HBr in presence of peroxides. So the double bond is over here. It does not happen across the benzene ring. Benzene ring is stable. While finding out the products, we should not blindly follow the Markovnikov rule or anti-Markovnikov rule. We should know the relative stability of the intermediate. So actually in this example, addition of HCl is following anti-Markovnikov rule. Addition of HBr in presence of peroxide follows Markovnikov rule, because the stabilities of the intermediate is more important criteria. So if you take addition of HCl, the carbocation at the benzylic position is more stable than tertiary alkyl position. So it's going to add chlorine here. So the carbocation is more stable at the benzylic position. So chlorine is added to that carbon. In case of HBr and peroxide, the free radical is stable at this position, benzylic position. So Br is added to other carbon atom. The carbocation or free radical, because of the stability at benzylic position over the tertiary alkyl position, this kind of products are obtained. Next reaction, alcohols using hydrogen halides. Alcohols, when we react with hydrogen halides to give alkyl halides, to prepare HCl, to prepare alkyl halides, we use HCl in presence of ZnCl2. This reaction have carbocation intermediate. Again, rearrangements are definitely possible during the course of the reaction. And combination of ZnCl2 and HCl is known as Lucas reagent. To prepare bromides, we can use NaBr and H2SO4, which can produce HBr. And to prepare iodides, we can use NaI and H3PO4. Using PCl3, PCl5, SOCl2, starting from alcohols. Alcohols on reaction with PCl5, PCl3, SOCl2 give respective alkyl chlorides. And these are the general reaction for all the three cases. And the best method among the three is using thionyl chloride, the last step, because both the byproduct SO2 and HCl will be gaseous and escape out of the reacting system, giving pure alkyl chloride. If chiral alcohol is used with thionyl chloride in presence of pyridine, the configuration is inverted, and in the absence of pyridine, the configuration is retained. So if I use a chiral alcohol as a starting reactant, due to the reaction of SOCl2 in presence of pyridine and absence of pyridine, we get different products. In presence of pyridine, there is inversion of configuration takes place, and in presence of pyridine, in the absence of pyridine, configuration is retained. Example, what would be the product for the following reaction? So first case SOCl2 is used without pyridine. Second case SOCl2 is used in presence of pyridine. As I discussed earlier, SOCl2 in the absence of pyridine, A, this should be retained, and presence of pyridine, it should be inverted. Why this will happen? In case of A, SOCl2 is used where intramolecular reaction takes place, which will retain the configuration, and in case of pyridine, it will follow SN2 reaction mechanism, which will proceed through inversion of configuration. From silver salt of carboxylic acids, it's called as Hunsdiecker reaction. Whenever silver salt of carboxylic acid is reacted with chlorine or bromine in presence of CCl4, gives respective alkyl halides. The general reaction RCOOAg plus Br2 gives RBr and CO2AgBr as a byproduct. A reaction follow a free radical mechanism. It is known as Hunsdiecker reaction, and the order of yield is 1 degree greater than 2 degree greater than 3 degree for the halides. Through allylic substitution, when alkenes are reacted with halogen at high temperature, allyl halides are obtained. The reaction is also carried out using N-bromosuccinamide, and N-bromosuccinamide is a specific reagent for allylic substitution, and the mechanism involves the formation of bromine at a very low concentration, and this low concentration helps the reaction to proceed through substitution rather than addition. If more than one allylic positions are present, then substitution takes place at a position where the free radical is most stable. We'll take one example for this. What are the products for the following reaction? The first one, compound A, we can see that there are two allylic positions. One allylic position is here and the second allylic position is here. But this is a primary allylic position and this one is a tertiary allylic position, and this is more stable. So bromine substitutes at the tertiary allylic position only. And in the second example, we can see a double bond outside the ring. So when the free radical formed, we have this free radical allylic position. This is the allylic position. This can undergo a rearrangement so that the double bond can come inside the ring, resonance stabilized. This is CH2. The double bond inside the ring is more stable and the product obtained will be this one. So you can see the bromine going here and bromine going here in this particular example. In compound A, free radical is more stable at the tertiary position. In product B, the product at the double bond inside the ring is more stable. Halide exchange method. When alkyl chlorides or bromides are treated with sodium iodide in presence of acetone, gives alkyl iodides. This is known as Finkelstein reaction. It follows SN2 reaction mechanism. When alkyl chlorides or bromides are reacted with heavy metal fluorides to form alkyl fluorides, this reaction is known as Swart reaction. So these two reactions are meant for getting iodides and fluorides specifically through halide exchange reaction. Thank you.